let's say you did not measure in shear, okay, you can take the tau max is equal to 250 divided by 2, which is equal to 125 megapascal. And this is through Tresca criteria, okay, without doing shearing test. Okay, and it's a pretty good assumption. Okay, so if you see down here, so the difference between experiment and Tresca criteria, okay, is basically 145 minus by 135 divided by 125 times 100. Okay, so the difference is what? 20 divided by 125 is 16% difference. Okay, which is not bad. You don't need to waste time to do tests. Okay, likewise over here, right? We have it as 260, and the experiment is 130. If you don't do experiment, you use Tresca, is 100 and what? 30 megapascal. So again, the difference is about 20, is less than 16% in this context. Okay, so if at any time you were to design anything and you don't have the shear property, just use Tresca criteria, or later on we can also use Vomi's criteria. Okay, so this is how we relate the Mohs circle now. Again, what we have drawn down here, you can see that this is our 3D Mohs circle. No doubt it's just one circle. It's one circle because of the what uniaxial test, because stress Y and stress Z is equal to what? 0. Okay. So now the Tresca criteria, okay, so we know that equation 1, right? Equation 1 over here is from experiment. Okay, it's stress U divided by 2, right? However, based on, so the next thing I want to tell to highlight to you all, based on our 3D Mohs circle, and structure analysis, right? Tau max, okay. So this is equal to the maximum stress divided by 2. Okay. So this is our equation number 2. Okay. Now, when do we actually satisfy this condition? Okay, when do we satisfy this condition? So equation number 2, and number 2 is when one of the principal stress is at stress mean, okay, and is equal to 0, okay, and the other two principal stresses are either both positive or both what? Negative. It's either both are positive or both are negative. So let me elaborate on this or not. It can look pretty confusing. So what if now, okay, we have a 3D Mohs circle or a 3D element X, Y, and Z, and then we have our element, and our element is such that we have a tensile stress in stress X. We have a tensile stress in stress Y. Okay. And then we also have a shear. And then that's all we have. So what we have in this context is you have stress X is greater than stress Y, and both are tensile. Okay. And we have a shear XY is equal to shear YX. And for this case, it is positive. And then we have stress Z is equal to 0. And the other component, the shear XZ is equal to the shear ZX is equal to 0. And then you have shear YZ is equal to shear ZY is equal to 0. Okay. So I'm going to sketch this out in 3D Mohs circle. So over here, this is your X. Over here, this is your Y. And over here, this is your Z. Okay. So I'm going to sketch 3D Mohs circle out. Okay, and I want you to look at the trends. Okay. So we have over here, this is our normal stress. And then we have our shearing stress. Okay, so this is our shear stress. Element rotate clockwise, element rotate anti-clockwise. And then we have our stress X line. Okay, we have our stress X line. And then we have our the other line, which is our stress Y line. Okay. Again, this is just a sketch. So this is our stress Y. Okay. And then we have our shear. And then we have another shear over here. Right. And then with this, we identify our point X. So point X is the element is rotating anti-clockwise. And this over here is our point Y. And over here, this is our point Z. Okay. So now when we sketch the line look like this. Okay. So we have our XY, right? Then we draw our first Mohs circle. So this is our Mohs circle. Okay. So we know this belongs to our XY plane, right? And then I'm going to sketch the other circle. Okay. and the other circle is here. And this belongs to our YZ plane. And then the last circle that I'm going to sketch, I'm going to use 2 there. So this is our last circle. So that's why we have to use 3D mold circle. You cannot use 2D, okay? You have to use 3D. So over here, we have we have our exact plane. Okay. So now we know that at this point over here, this is our stress A. Over here, this is our stress B. And over here, this is our stress C. Okay. So what we want to determine now, okay? So whenever you use any of these yield criteria, you have to construct 3D mold circle, okay? Because this is the reality, okay? You cannot just rely on 2D mold circle. If we just rely on 2D mold circle, in 2D, we only sketch the what? We only sketch for 2D mold circle, you only sketch the what? XY plane. So on XY plane, the circle is not the biggest, is it? Right? You have to sketch 3D mold circle. So what we are trying to identify now, and what we are trying to determine now, is we want to determine this value over here. We want to determine this value. We want to determine this value, tau max. And this tau max and this tau max are the same. Okay, so these two are the same thing. Okay, these two are the same. Okay, these two are the same. I will use a different color. These two tau max are the same. Okay. So this tau max, right, is equal to stress max divided by 2, right, as you can see. So if we were to do the math, okay, so we know that stress max, or now we would like to calculate our tau max. Okay, we're like, and to calculate our tau max, we know that this is equal to stress max divided by 2, right? So by referring to this 3D mold circle, note what's interesting is stress max is equal to stress C. Okay. And to determine stress C, right, now we want to find stress C. Okay, how do we find stress C? So what we're going to do is I'm going to call out this line over here. Okay. And this green line and the distance from here to here, right, this is our stress average for XY plane circle, right? This is the stress average, okay, for the XY plane circle, okay? And then later on from here, we also have to find this radius. So we have to find the radius, okay? So the radius for XY plane. Okay, the radius for XY plane, or the maximum shear stress in the XY plane. Okay, so now we have to determine what is